Alright, guys, let's continue with the next part. I just want to welcome you again to IIC Rise. The process, the plan in this program is to cover almost everything about Python, and we are touching from databases to data science to web technologies to menu-based program, voice control, tons of guys program we have discussed and we are going to discuss in this training. But initial focus would be more about to cover the concept, maybe file handling, maybe exception handling, maybe socket programming. And guys, yesterday we have started at the socket program, right? So again in my networking, I have a huge plan to be discussed. Sorry. So yesterday we have discussed about if you want to transfer some data between two computers, two VMs, or two different maybe mobile phones. Okay, obviously one thing that we need is having the network connectivity. But if a computer want to transfer some data between the B, sorry guys, if we want to transfer some data to B, okay, so first of all, the first core need is, okay, because A is transferring some data, and obviously guys, they have to transfer data inside a network packet. So there will be somebody on the B who will receive this data and who will access this packet, and that somebody is some kind of process or some kind of program. But this program should have a capability to receive this packet. Okay, but so that for this, our developer has to create a program, and in the program they have to enable a capability so that when this program will launch a process, that program will have a capability to go to network card or to the network layer and to receive this packet. Okay, or I can say in this way that the computer B is the one who decide in this program, in their code, they want to receive data from the network card or not. And let's say B say I want to receive my data in my network card. So I am giving my program, or I can say I'm giving a process some unique ID, some kind of network ID. Technically, you guys know that's called port number. So in my yesterday class, guys, I have given up my process a port number called 1234. So who will decide? Okay, A computer never decide. Okay, this always decide by this B program, who are going to receive this data from somebody else. So they decide their own port number. And they also decide they want to, when anything come on this port number via network, they want to receive or not. So in the code they have to write some kind of function. For example, yesterday I use a function called receive or receive from function. So they write some kind of function like receive from, maybe the spelling would be so some kind of receive function or receive from function that decide they want to receive this data or not. Okay, but the interesting thing is this till here we have discussed yesterday, but let me add one more point here, because B is the one who decide I want to access my data on this port, or I can say the way I explained you yesterday, that my process has one more name. Okay, and name is known as socket name. And if you guys know, every computer has a IP address. Yesterday my computer IP address was 129. So B say I am going to run a process, and the name of this process is also defined by my IP address and my port number. And guys, this combination is called socket. So anybody who want to send a data to me, I am a B computer, use my socket, connect with my socket and send the data. So if A want to send the data, okay, and obviously guys, if you want to do something on the computer, either you receive the data or you send the data, whatever you do, you need some kind of process by some program. So if A want to send some data, they have to create a packet if they want to send the data via network. But who will create the packet? Obviously some kind of process will create the packet. And for this, everything you do in any of the programming language, you have to create a function or you have to use a function. So yesterday I used a function called send to, and this is the function who send a packet or create a packet and send to this IP on this port number. Okay, but one interesting thing and one important thing that we have discussed yesterday. Okay, B is the one who create a process, and in this process they give a socket. Let's go port number. Or because B is the one who say I am the one who going to receive data from somebody or from the sender. Okay, so I am the one who will decide the protocol that I want to use. Okay, so for me, whatever data A will send to me, maybe that data might not be so much reliable, but I might require some kind of great speed. So I will connect from A to B using a concept called connectionless. And guys, if you want to use a connectionless, then the protocol that you have to use is called user datagram protocol. Okay, but this protocol has some limitation. I already explained to you, and to solve this limitation we have to go for other approach of connectivity. Is called connection oriented approach. Let's come into the protocol called TCP. The good thing is this training, guys, I'm going to show you both the protocols and how to write a code for UDP also and TCP also. So yesterday I started with UDP. One of the reason is it is very simple to do, but after you guys comfortable with the UDP coding, then converting this code into TCP won't be a big deal. But interesting thing is, okay, why I started as a UDP protocol code, because I'm going to write some code today, and you will see on those code that is providing a facility or implementing a protocol called UDP, okay, has some kind of limitation. Some of the very important use case we need in today's world not properly managed and processed by the UDP, and automatically you'll see there's some kind of need arise, and whenever anything need arise, or we always come with a new idea or new, here in this case, protocol. And that will be the great example that will actually explain you what is the actual need of TCP. Okay, because by this term connection oriented, because this is a very commonly used term we always see in the market, that TCP is connection oriented, TCP is very reliable, UDP is connectionless, it is not reliable. Just by this term, the term is right, no doubt, but this term doesn't explain you actual need of the TCP. Okay, so I feel if you really understand what the power of TCP and why we need TCP, if you have a UDP, just try to write a code in the UDP and try to see what at most or at max you can do with the UDP. That's I'm going to show you today, and you will see by the end of today's discussion that there's some use case that can't be properly solved by UDP, and it ultimately leads us to a new topic that's called TCP protocol. And we also show you how to write a code in the TCP. Okay, so guys, my yesterday demo was on two computer. For the A, I use Windows operating system, and for B, I use Linux. You can use vice versa, because I use Python, and Python is cross-platform. You can do a code in any of the ways you want. Okay, so that's what I'm going to do here. I'm going to launch my same Linux operating system. We have to add some more thing today. Okay, and some more concept, guys, I'm going to explain you today. So this is one of the OS I'm launching, my Red Hat Linux, or you can use any Linux. And for Windows, I'm using my command prompt, and we have created one workspace. Okay, for in Python Rise, and I'm launching my Jupyter notebook. Okay, and according to my yesterday process, okay, we are going to write a program in the Windows, and the duty of this program is to do only one thing, to send the packet. So I'm going to create a sender program for the UDP protocol in the Windows. And why UDP? Because Windows here as OS is going to send the packet, or because they're sending to the B computer, to this process, to this program or this protocol, this port number, because they say I only accept UDP. Okay, and if the receiver say I only accept UDP, so as a sender side you can't do much. The only choice that you have with you, that you have to set the or send the packet with, obviously inside the packet we have a data, using a protocol called UDP only. Okay, but if you want to send a packet, okay, either UDP or TCP, you have to create a program. So technically you have to create a program in both the sides, because without the program, no process, and without the process, you can't deal with data in any of the site or any of the other concepts also, or maybe in any other technologies also. Okay, so what exactly we are going to do today? So again, I am discussing some more thing about UDP, and by the today's practical, I am going to explain you some more concept of the networking that is very much useful. Okay, but before this, I just want to tell you one more concept that we are going to use today. Okay, so in this guy's complete diagram, A is going to send some data inside the packet to IP 129, okay, on the port number called 1234. And this port number is just a program name. I explained it's called socket name also. Okay, so whatever data you send at this process, the process will attend or they will receive by some kind of function, the way I used yesterday. They receive, and after they receive, right, what receive function I used yesterday, what they do, they will go inside the network card or wire or wireless, they retrieve this packet with the data. Or because this is data, because this is data, and we always store the data in some kind of variable. So yesterday I stored this data in X variable. Now it is your choice what you want to do with this data, or I can say it is a choice of the developer who create this program, how they want to deal with this data. Okay, so what I mean by this, so after you receive the data, do you want to print the data? That would be your choice. Yesterday guys, we print the data. Or after receive this data, you want to take this data and you have some program written in Python, and you receive this data, and there's one program, and through this program we send a mail to somebody with this data. Or maybe you receive data and you store this data in one file. You guys know how to do file handling. Or maybe you receive this data, and after receive the data, you treat this data, or a string is not like a normal string. You treat this data as a program, or I can say as a command. Or you tell your own process that the data that you receive is not a normal data or normal string. I am treating this data as a command. So I want, rather than you print, run this data or string as a command. Okay, what I mean by this, when I go for develop this code today, you will understand right what I'm talking about. But the main thing I would like to elaborate here is, okay, after you receive program, receive the data, right? This is the choice of this process, whatever we write in the code, what they and how they want to manage or handle this data. Okay, so it is something like this. You can think in this way. A sends some data in the packet, and let's say data contain a string called hello. And A hand over this data to B program. Okay, and what B program is written in the code, after I receive data in X variable, I have a mail function. Mail will send a mail to somebody with a data called hello. So technically, finally guys, if you conclude, it look like, okay, B is running some process on this port number, and this port number is giving a facility to their senders after receiving the data. Okay, and what facility they're giving, they collect the data from the sender, let's say hello, and they're helping me to send the mail to somebody. Okay, or they're helping them to store the data in some file. Or they're helping them to get this data and treat this data or not as a string. Maybe you send a data called date. So for the A, a date is just a string, but after B received date, they say date is not a string. For me, it is a command or Linux command. I will run as a command output. I will run a command output. So B is running a process. What B is giving a facility to the B. Sorry, what B is giving a facility to A. Or I can use one more term here. B, he is giving one kind of service to A. And say, A, I'm providing you one service. I have a process running on 1 2 3 4 port number. Whatever data you send, I will collect the data and mail this data through some ID. Either you provide it to me, or I have some ID written in my code and I mail there. Okay, so technically, if any program running on the internet or the network, in this case B, and some port number, and if they're giving some kind of facility to their sender, then this kind of receiver program is also known as server program. And guys, that is the meaning of the server. Yesterday somebody also asking me in the chat message what is the actual meaning of the server. So guys, this is the actually how server work. Okay, so guys, if you heard about server called mail server, file server, database server, a remote login server, okay, remote command execution server, SS server, this is how actually they have constructed. Okay, so your receiver program is the one, they decide what they want to do with the data. Okay, or in this case, A is the one, they say I am sending some data to you, hello or date or somebody email ID, and I want I'm looking for the service from you. Because you are the one who gave the service to me, or I am the one who taking the service from you. So my program is also known as sender program, but technically in this context, this program is also known as client program. So A say I am a client and I have written my own program called client program. I'm running a client process. The duty of client process is to just send a packet with some information and with some data. Now how you deal this data, that will be your choice. After receive, you want to mail it, store in database, run as a command, and something like this. Okay, so technically, if you guys heard about web server, mail server, SSS server, tenor server, this is how they work behind the scene. Okay, so let me guys show you how to create your own server. So technically, if you guys go through my yesterday class, we have written the entire code. We have to just tweak this code for some changes. Some change we'll do there, and you'll see just same code we have converted into a server program. And I told you guys yesterday, the way I start my my yesterday topic, I told you maybe till date, guys, you guys might have configured the server like mail server, web server, remote login server like SSH. Okay, but maybe you haven't developed any server yet. And this is the first time today we are starting our journey to create and develop our own server, or sometimes is also known as services. Okay, and we are going to develop our own client. Okay, and one of the great example of the client is your Firefox or your Chrome browser. So this also work as a client, and this client will go and contact to Google web server. So guys, this is not the web server. What you see in right now here, it is just an application. For example, if you go and see in the Facebook, it is just an application. But before the application, guys, you have always connect to the web server. So guys, if you go through my Python CGI classes or API classes, they explain you a lot about application, but I also explain you about web server. And I told you guys, application is a different thing, web server is a different thing. Okay, so browser always connect to web server, and web server will do something and give the application to you. Okay, so maybe guys, in that training of my Python where I explain you CGI or the API, I only I only talk about how to create the application. But there we use a web server that is called Apache web server, and that Apache web server is not developed by us. We use some product from Apache company called HTTPD, and that product and software is developed by somebody else. So I can say we use HTTPD product, Apache web server product, and configure it, set up it for our use. Okay, or I can say we configure the server. But today, guys, we are talking about how to create our own server, how to develop our own server. Maybe Apache, web server, maybe mail server, or maybe any other kind of server. Okay, so it's a huge difference, guys. What I'm trying to explain you here is okay. So let me again start the thing. So what I'm doing here, we had created one folder here. I don't know which folder I've created yesterday. So we had created one folder. Let me very quickly create this folder again. So let me use this is called Rise Workspace 1. And what I'm going to do, I'm treating this computer very quickly. If I draw this very clean diagram here, so my current computer IP might be 129. Very quickly, let me check. So this is the network card of my computer. IP is 129. And I'm going to create a server program here. Okay, server means it exactly the same. We are going to create a program or a process that has a port number with that is linked with this number. So number and the port number means socket. So this process has a socket. And guys, if you give any process or any program a socket, that is called bind. So we bind a socket to this process. Socket means IP address with the port number, the way I show you yesterday. But this process not only having a socket means if somebody from Windows or some other OS, if they send the data, so this process is not only sorry, receiving the data. After receiving the data, they will provide some kind of service to you. Yesterday, guys, I just only used print. Okay, but print is not actually service. Whatever data you receive from Windows, you get the data, send somebody a WhatsApp message, send somebody mail, or store something in the database. So that is a called service. So if you change something in the process, I can say something in the program code, then I can say I'm creating my own server program. So coding wise is exactly the same, but after receiving data, you will do some changes here. Okay. So let me do it very quickly. Okay. So what I'm doing here, I'm going to create again the code, and today I'm going to give a code a name, server1. You can give any name, whatever you want. It's a file name actually. Okay, and what I'm going to do here, I'm going to import a socket. And today, guys, I'm going to create a code with a UDP protocol. Okay, and so because we are using UDP, so I'm going to give a socket name or protocol name called Daga because it is a UDP. And I told you guys, we have to tell my program that we are going to use IPv4 address. So my address family is IPv4. And I'm going to store this guy into S variable. I'm telling my S that this program is going to bind, or this sorry, this particular program is going to bind with my IP address. My IP address is 129. This is my current IP address, and my port number is, let's say, 1234. So in the bind, we have to provide first for IP address and the port number. So guys, this IP and port number combination is called socket. And because we are giving this socket number or socket to server.py process, I can say this is called binding. Okay. And after bind this, then this program has a capability to go to the network and receive any data come to this port. But who gonna receive? Okay, so we have to use receive from function. And here we have to give some size. You can at most can receive total 100 bytes, or let's say 10 bytes. And after you receive, we store this data in XML. But till here, guys, we have done the code yesterday. Okay, but just for testing, I'm again doing printing X. But after you receive, how you want to deal with this data? Okay, printing is not the way to deal. You can use this data to send the mail. You can use the data to run as a command, the way you guys know, maybe SSH or telnet. So that time I can say now this process or this program is work as a service for the customer or for the center. So I can say this program is a server program. Okay, but let me just run this code over here. Okay, so I'm running this code. There's no error come up. And now who gonna use this? Some of my sender gonna use this. And now, guys, why I'm using the word sender here? Because whatever sender will send, my server program or my receiver program is only their printing. But if they're doing something else, Then instead we use the word called sender, sorry, the receiver, we use a term called sender. So we'll show you how to do this. Okay, but right now I'll go to my Windows and I'm going to write one code here. Okay, and because your receiver program say I am using a socket and my socket is purely based on address family called inet, means IPv4, and my socket is purely based on UDP. So if you want I receive something for you, you have to again use the same protocol. And if you want to send something, then we have a function called send to. Okay. So I can do in this way. Even though, let me create one variable here, and here I'm going to give the IP of the receiver. Let me use the word called server IP, and let me give the server port number. Let's go 1234. So I'm telling to my Windows, if you want to send some data, this is the IP you have to use of the receiver, or I can say server, or this is the port number you have to use. So I'm storing this guy into one variable so that if you want to change something in the future, we can change. Okay, and if you want to send now data, so let's say I want to send some data, and my data is hello. So this data I want to send. So how to send? You can tell your S socket variable that I want to send something. And what I want to send data, and where, which socket, server IP, comma, server port. So this IP and this port I want to use. And if you run this, and guys, I told you when you want to send something in the Python version 3, whatever data you send or receive, data they doesn't support string data type. You have to convert the data type into bytes. Okay, so that's what I'm doing here. So one of the way to convert the data into byte, you can start with B, or you can use encode or decode function. Even though if you just very quickly see what is data type of this data variable, sorry, is the bytes. Now if you try to send it, it will send for you. Total 5 byte bit transfer. And because in the server program, or I can say here the receiver program, right, because we have given a limit, I think, of 10 total character they can receive or byte they can receive. That's called buffer size. Buffer size. So because I send 5 character, so or 5 byte, they definitely receive for us. And after they receive, where I mentioned the size here, total 10 we can receive. So 10 character we receive because we have only 5 character come up. Okay, they receive it. So guys, still here I have we have constructed yesterday. I very quickly revised the code, but my intention is to actually explain you some other concept, and the concept was purely based on server and the client. Okay, so but before guys, I will go properly and to show you how to create the server. I just want to tell you one more thing. Whenever any receiver program, or you can use one more word called server program, receive any data from the sender program, or maybe you can use a word called client program. Okay, they definitely receive the data. Because by chance this is Python 3, so they always receive the data not in the string format, it is on the byte format. Okay, but they also receive one more thing here, and guys, this is the socket of the client. Like server has socket, IP and port combination, client also have a socket. Okay, and like server has a port number, client also have port number. So this is a port number client, and by chance they are random port number. Right now guys, I'm not discussing anything about the client port number. Those they don't have any logical reason here to discuss. Maybe if you want to discuss, we might discuss in some other classes why client need a port number. But every client in the world, maybe you guys know networking, so you guys might know, always server has a port number, right? It's not like this. Both the side, it is compulsory to have the port number. Okay, but why client need a port number, we might be discussing in my next classes. Okay, but the important thing is because when the client send any information or data to the server, client always send their IP address and their port number. IP address, let's say, is not important right now, so port number is not important, but IP address might be important. Okay, so it means your receiver program or your server program always know who is sending the data to you. Okay, now it is your duty in the receiver program. Do you want to use the client IP somewhere or not? Maybe I can use this IP, or I can store this IP in some file. Okay, and why I want to store? Maybe in the future, after 1 or 2 days, I want to check yesterday all the IP who sent the data to me and which time. So I can store in one file my time and the IP address of the client. Okay, and guys, this is very common practice in the real company, the real server we always use. So whenever any sender or client sends some information to the receiver program or server will always store the IP of the client. Here guys, my case IP is 140, that's my Windows operating system. Okay, why they store? So that if any kind of hack happen or any kind of issue happen, we can go back, look into the file, and from the file we can find, hey, at this time from IP 140 they come to us. And guys, this kind of file typically in the server world is known as a log file. So they create a log for us. Okay, but how my server, maybe guys, if you heard of a mail server or Apache web server, they also create a log file for you. But how sorry, how the log file or how the Apache web server come to know the IP of the client? For example, if you connect to Google, if you connect to Facebook, they know your IP, because whenever you connect to Google or maybe Facebook, you always you always send your IP. So right now my IP is always go to Google. Okay, and this is not decided by you, it always go, because this is the Chrome browser I'm using, and if you want to send any packet without your IP, your packet never go out to the world. Okay, and that is a reason if you ask Google, do you know my IP? So you can type here, what is my IP? I'm not printing here because my live session is here, but if you type here, Google, do you know my IP? My current IP, I am your client. You can type here, what is my IP, and it will show you the IP address of my computer, that what I'm using here in the public internet. Okay, so something like this. But you can use, maybe you can use this IP for other purpose. For my case, what I'm doing here, I'm just using and printing this IP. Okay, but by chance guys, if you see here the structure, how they give you the output. So if you see here, my receive program receive this data. So this is my receive program. They received the data from the sender and they store this data into one tuple. Okay, and this tuple, they store two information, one at the index number 0 and this entire socket information at the index number 1. So if you are only interested to just to, guys, whenever you receive function, you always get the entire information. But you think, no, I don't want to get the entire information, I am only interested to retrieve my client IP. Okay, so pretty simple. X is one variable, and in the one variable at the position number or index number 1 we have entire information. Okay, and even though if you see here, okay, in the index number 1 we have again one more tuple. If you do, those guys who don't know tuple, it is like a list. And again this list has index number 0, index number, and my IP stored in the index number 0. So if you want to only retrieve IP address, you can use. And I can say here the client IP. So if you are interested only to print the client IP, you can print. If you don't want to print the entire data or entire packet coming from coming from the client, you can just go and retrieve the client IP. Okay, so now what happened? Now this receiver program is doing only one thing for you. So whenever anybody send a data to me, for example, I'm running this code again data send, and this data send from Windows, my case IP 140, and my server, wherever they are running, or maybe on internet, maybe in other computer, they receive and say, hey, I know you who send data to me. So 100 computer send data to, I can receive all the IP of all the 100 computer. Or they are not interested in to pick the IP, they only wanted to retrieve the data. So in this receive function, In the X, my data is stored in the position number 0. Okay, so I go and say, can you please go for X variable, and at the position number 0, we have our data coming from the client. So I just want you just print data for me. So depend guys which information you want to use. Accordingly, from this X variable, you can retrieve those information and use in print, or maybe you can use another way. Okay, now if I run this program again, not same program, just by changing small code. Now if I run this code again at my sender side, again this hello data will reach there, and here they print only hello data. And that's all. Or maybe pretty simple code guys you can also create, or maybe I can say I can write in this way, client IP, then plus, then I can use colon, then plus. So this is the one string I have, I concatenate with other string, then I concatenate with other string. So the final output would be something like this. Would be something like this. So again, if my client send a data to us, so so server receive the data and they print the data in this format. Okay, so output guys, they give the error. Why? Because whenever you receive data again into the bytes format. And if you try to add a string with byte, it give you error. So you have to again convert your data into the string if you want to use. Okay, and if you want to convert the byte into the string, I just try to show you the function called decode. Okay, so this string this byte I'm converting to the string format. Okay, so if I run this code again, now you can see output come like this. So you can think guys, now you can create a program, something like a group chatting, or some kind of broadcasting message. So I run this program. Okay, and this program is keep on receiving data, and they keep printing from IP 140 we get hello, from IP 141 we get something else, from IP 1 or this IP we get this message. So keep on running this program and they show you on the live, okay, which IP sending which kind of data. So one kind of grouping or group chat kind of program, or broadcast message kind of program you can get. Okay. Or maybe you can think as a company perspective, you create one program inside the company lab or the data center, okay, and tell everyone that anybody who has some kind of issue or trouble, just contact to this IP at this port number and send me your query, what kind of message you are getting. Just keep on broadcasting. So it is like this. In the server, we create this open IP, open port, and the guy who have connected with me using the network or inside my network that has a direct connectivity, they keep on sending the data, and somebody is sitting on the server console that's called operation center. Okay, and they keep on saying, hey, this IP has this issue, this IP has this issue. So multiple applications you can create just by simple example over here. Okay, so this is one of the very simple application you can create by this example. Okay, this is one thing. But for this, if you see, there is one challenge here. If some of my sender send some data to me, as soon as they send the data, as one sender send the data, my program receive it, they print it, and my program terminate. Okay, but again, one more guys want to send this data. Let me run this code again. Okay, if you see here, they send the data, or let me change the data also, like 1 2 3 4. Okay, again somebody send the data of 10 character length, byte in size. So sender send the data, but we as a receiver we haven't received. Because I told you guys, whatever you want to do with the data, you have to run your program, you have to start the process. Right now there is no process, so so there is no meaning that this system will receive some data from somebody. But if you see guys here, my sender is sending data, but they're sending the data this IP and this port number, and this IP is there, but there's no port number available. Okay, even though even though normally in the networking world, if you're trying to kind of register some IP and some port number, if some of the thing is not available, normally your send program will give the error. But in this case, they are not giving any error. Why? Because they are using UDP protocol. And UDP say, I am not reliable. I will keep on sending data. They are live or they are not live. They are available or not available. So I don't, I won't wait for any acknowledgement from this IP and this port number and program name. I keep on sending. If they are available, they receive it, they use it. If not, they will discard. But I will keep on sending. So this is not good. Maybe in some case it's not good. So maybe this is one of the case where I would like to use TCP. But there's a lot of more use cases where we have to use TCP. We'll discuss. Okay, this one thing. So what I'm trying to tell you here is, as soon as the sender send the data to you, your server will receive your data only once and the program complete. Means it always go run the program, then you call to your sender, do you want to send some more? Just go here, send to me. Okay, and they will receive. Again they close. Okay, why is happening? Pretty straightforward, simple reason. Because who is receiving your program? Sorry, who is receiving data? Okay, so this port number is just my program name or my socket name. Who is receiving your data? A receive program. So receive program, guys, is something like an input function. For example, if you use input function, you can use input function for one time. So if you give some input to the input function, that's all, they close. But if you want to use input function again and again, what do you have to do? Put the input function in the loop, that's all. Same thing if you want to use receive function again and again, again and again, then you have to put this function inside the loop. Now you can use for loop also, while loop, both the loop you can use, but technically I already explained you the use case of while loop and the for loop. In this case, we don't know how many clients want to connect with us in the future. Maybe one client, thousands of clients, I don't know. Okay, so guys, if you remember in my menu topic, I explain you, if you don't know how many time client gonna use your menu, so we always use while infinite loop. So keep on allowing my client or my or sender and just keep on ask them to keep on sending the data. So I use an infinite loop here. Okay, so because this is the infinite loop, so you have to properly indent your code. Okay, so now what happened? We give a program obviously one time a name or called socket. But after we get the socket, we run this receive program again and again. They again collect the data. They again decode the string into bytes and also a string, and they will print for us. Okay. Now, just by changing this program little bit, okay. And now if I use and send this data, click, I can see they see the data. Or maybe some other guys want to send the data. So maybe my other Mac OS, my mobile OS, they also write a program, something like this. It's called UDP programming. Or there's a lot of program available in the market or command available in market. You can also use that program, pre-created apps also. So if you go and search in the mobile, any app for the UDP, you can go and install that app. That app will ask you the IP address of the receiver and the port number. And they ask you what data you want to send. Just click and they will send the data. Or you want to create your own code, you can use this one. So let me change my database data here. I want to send something like DT1 something. Okay. Again, we send this. Okay. And if you see here, again, this data also is. So now this program is keep on running for you ever. And we keep on receiving the data. And we keep on printing. Okay. So that is a cool thing here. Okay. Now guys, let me, because this is an infinite loop, if you want to stop, just go to your receiver side. The receiver program is running. You can, by chance here, you can use Control-C to terminate the program. But there is other way also to terminate. That's a different part. We'll discuss. Now, I just want to do some change here in this code. Okay, but let me share this code to you first. So, what I'm doing here, sorry, in this code, now it is your choice, guys. sorry, just guys try to focus in this example. Now it is a choice of my receiver program after they receive the data. Okay, by chance they receive the data, and they receive the data and store in one variable called data variable. Now it is their choice, they want to print this data. Okay, very quickly if I show you here, same thing. And if I go to my sender side, so they want to for example, I'm sending a data or a string called date as a string. Okay, so guys, from the sender side I am sending a string called date. Okay, now it is a choice of my receiver program, in my case IP129, how they would like to handle this string. By chance in our case right now, they only print the string as it is, whatever sent to us. Okay, but your sender say no, I don't want to only print the string. Instead I print the string. What I'm going to do, I put this string into a function called system function. Okay, so understand one thing, you guys know what the use of system function. Anything that you put inside the system function. Okay, system function is the one who treat this string not a normal string. They convert this string or they run this string as a command. Okay, so technically you are receiving date as a string, but you're asking your receiver program, okay, I would like to use this string and to run as a command. So in this case, this receiver program is providing you one facility, and this facility, guys, is also known as one service. So I can say this process or this program become a server program. And what facility they're giving, they're not mailing for you, they're not storing any file for you, they are running this program as a as a command in the program. Okay, any program or any remote program I can say, because according to A, B is a different computer, it's called remote computer. Or any remote computer, guys, after they receive data on some socket in some program and they run this data as a command, then this kind of program is also known as remote remote program execution. Okay, so I have created one remote execution or command or program execution server. Typically you guys might have heard about telnet server or maybe have heard about SSS server. So these are pre-created server. Somebody has created this server or software for us. Okay, but today I'm going to show you how this kind of process and program has been created. So we have created our own program who take the string from a computer or sender, get the string and don't treat it as string, they will run the string as a command. So in this case I can say now this receiver program is work as server and this sender program is work as a client. And guys, this is called client server or server client relationship. So we have created, guys, client or server client program. Okay, we have created. So let me show you. But guys, you guys know system function is a part of OS module, you guys know this. And for this you have to import the OS module also. Okay, now I run my code again. Now in this case we have created a program. Now this is a service program or server program. The good thing of this server program is now from any of the computer, okay, somebody will connect to my this IP and this port number, those guys who have connected. And when they send any data, so for this client they are only sending a data, but when they receive by the server, they run this data or string as a command. Or because they run the as a string command, you can see the output of date command come over here. Right? Or if they want to send a data that has a string called cal, and those who now guys know Linux, in Linux the cal is a one kind of command. So I'm sending a cal, but they will run cal as a command. Okay, and let me show you one more interesting demonstration here. Instructor-led, if I send a string called Firefox, okay, and according to me, I am sending a data called a string called Firefox. When this string received by a receive program, here it's called a remote server program or remote command execution server, something like SSS or Telnet. Okay, they receive Firefox and they run Firefox as a command, and when they run Firefox as a command, what you will see, Firefox launch. And guys, this is a very interesting program because because guys, if you know anything about Telnet or SSS, okay, it is very harder, even though we can do, but very harder. So from here to here, okay, from A to B, and in the B, if you have any command or program that work with the GUI graphical, and from A, if you want to launch any program in the B via networking, it's called via remote login or remote execution. If the command is CLI based, command line based, like date command or cal command, it is pretty straightforward. But if you want to launch any program in the in the B computer that has a GUI graphical, okay, via Telnet protocol, if you guys know, or SSS program, if you know, uh, there is a possibility, there's a way, but little bit harder actually. Okay, we have to do some changes here, but very smoothly, guys, we have done this. Even though without using SSS or Telnet or remote other program or services, we create our own server and own client, and from the A, I launch a program on B that has a GUI support, maybe Firefox, VLC player, or maybe any other program you have. Okay, that is a great thing we do. So technically, if you think so, technology is so simple. If you know the concept, we can we can tweak the thing, and accordingly we achieve what I want to do. So now this program, just by writing this code, this receive program become a server program for run the code. But you can do some more thing here. You write some other code who will receive data and send a mail to you. So it become mail server, okay, or database server or file server. So or maybe web server also. Okay, so lots of things, guys, we can do and achieve over here. Okay, so this is, guys, one concept I just want to explain. So anybody who wanted to understand what is the meaning of client or server, that is the right meaning of the client, and that is a right meaning. I already explained you about the port number. Okay, but in this case, guys, in this case, I just want to again do small change here. And I would like to again print some information, and I'm storing printing the information called client IP again with some space, with some string plus my data. Sorry, guys. So technically, first my client IP print, then some colon string, then this data print. So I'm not using this program as again a server program. I'm just printing the data. So I'm doing this. There's a one small reason. Okay. So when I print this, when I run this, or let's say, guys, in my network, we have one more computer. Okay, one more computer. Let's say one of the computer is Windows having IP. In my case is 140. I have one more computer. I also want, for example, maybe Linux, for example, they might have a 123 IP, for example. So I want Linux also send this data to this guy. I want Windows also send a data to this guy. Okay. So obviously, guys, typically, normally we have only one receiver program or one server program and have hundreds and millions of clients. For example, Google is a one server and they have millions of clients. Every client from the browser, they connect and send the data. Okay. And interesting thing is, we run the Google run the server only once. But all the millions of clients, they keep on sending data in parallel in the same time. Okay, let's see if we can achieve this one. Okay, so what I'm going to do to demonstrate this thing, I have one more operating system. So I'm going to use one operating system, like for example this one. One more OS I have. So this is system over here is my receiver program, or you can say server program. So this is one of the system I'm going to use as a sender or a client, and Windows is my other sender or client. Okay, so what I'm going to do here, if I go to my server program again, they're waiting, right, to receive them some data. Or if Windows want to send, they send it. So they send this data Firefox, and they receive it and they print the Firefox as it is. But who sent? IP140. But in the same time, okay, this is my other computer. I'm logging to other computer. By chance, the IP of this other computer in my case is 155. Okay, so I have one more computer, 155, 155, and they also want to send the data. Okay, so can they send the data also with the same server? Okay, in the same time. Let's see, guys. So what I'm doing here, again, I'm creating some Python code. I don't know they have Python 3 or not. Oh, I don't have Python 3 installed here. So very quickly, please go and start my new different system. This system might have Python 3, so I'm going to use this one. Okay, but what I'm going to show you here is, because this is a very common thing if you are creating any server program, we create a server not for one single sender or one single client. I want sorry, I want hundreds of client, or maybe 10 of client will connect together. They send their the requirement, they send their request, they send their command, mail, and this server program will service all the guys in parallel. So I'm talking about, does this server has a capability to give a service to all the client in the same time? That's called parallel. Can we achieve this? Okay, technically, if you talk about one of the server called Google, they are doing it. So right now I'm opening the Google, I'm the client. You can also open, you are also client, but in the same time Google is giving service to all the guys. This server, whoever guys has created this server, has a capability to deal with multiple clients in parallel. Okay, so does our server has that capability? That's what I want to show you here. Okay, so this is one of my client or my sender computer. Let's see, guys, how they do. Okay, so let me show you. So this is one of my computer. Let me very quickly check the IP of my client or my sender, same thing. IP 163 in my case. 163. And let me very quickly write my Python code. And again, I'm doing the same coding. Or let me write the code directly in the file, because maybe I have to keep on changing my code multiple times. So again, I'm doing a socket program. Okay, s.socket and socket dot address family inet socket dot sock underscore datagram. It is in the capital letter. Okay, and s dot send to, and I'm sending some data. Let's say new client. I'm new client. Okay, and this time I'm converting into byte, and I'm sending to my server called IP129. Okay, and the port number called 1234. That's all. So I send the program, or I can say the client program has been created. Or let me run this code. So if you see your server is still running. Why they're running? Because we put the server in the loop, and in the server this receive program is running in the loop, and receiver is the one who has a capability to receive some data. Okay, recently they received data from IP140. Okay, now if I send some more data here, there is no error from the client side. They will definitely go here, and that is also received. It means one program has a capability to receive data from multiple clients. That is a by default nature, and this nature actually come from receive function. but it doesn't means it doesn't means that this program has a capability of parallelism. What I mean by parallel here, okay, guys, can you hold for a second, please? Okay, so guys, this is not a concept of parallel or receiving the data at the same time. If you see here, there is some delay here, some time back, maybe 1 or 2 minutes back, we receive data from this IP, and then we receive here. But when I say, does this program has a capability to get the data in parallel, means at same point in time, at the same second or millisecond, this IP and this IP, both the IP come with come with their respective data. This program will receive both the data and print it, use it. Does this program has this capability? Okay, we don't know. Let's go and check in some way. Okay, and how we can check? Let me maybe let me stop this program. Okay, stop this program, and maybe this might be not the perfect way, but you can get the idea. Okay, so what I'm doing, as soon as they receive, and after the server receive, they receive the data, and server is doing something on data, or maybe if server is doing something data, server might require some 10 second, 20 second. Because data is big, huge, server is doing some processing on the data to give some service. Here they are running the command, or maybe they are doing some other process, or maybe doing some analytics or machine learning. They might require some 1 or 2 minutes. So what I'm going to do here in the Python, we have function to if you right now, guys, I don't have any process that will keep on running here for some time. So what I'm doing here in the Python, okay, we have a function called sleep function. Again, whenever you use a sleep function, it will delay your program. So I'm running the sleep function, let's say for 60 seconds. But sleep function, guys, is a part of the module called time module, and inside the time module we have a sleep function. So what sleep function do? If I run 5, this will hold my program for 5 seconds or 10 seconds. So I'm trying to simulate the environment. What I mean by this, what I'm going to do here, so I'm going to run a time function, and inside my while true, what I'm doing here, I am running a sleep function here, just to give you give you a practical that illustrate you, as you receive a data from one client and you use your data and you do some process here, and let's say your process running for 300 seconds, just for example, means 5 minutes. Okay, till the time your process is running. All right, till the time, let me change to 120 seconds to 2 minutes. Till the time your process is running. Okay, you are this line, till the time your this line doesn't complete, they never go back to receive program, and till the time you don't go back to receive program, you won't get the data from the new client. What I mean by this, okay, if I close this program again, and if I run this program again, okay, and let's say one of my client send a data to me, or let's say they say I am Windows. Okay, Windows send the data. Guess here you receive the data from Windows, but same time one more computer can send the data to us. Okay, if you see here, it is not received. It received. Why? Because after you receive data from the first client, you receive I am Windows, or maybe your program is doing some data processing here. Maybe this processing data may require 1 minute, 2 minutes, or maybe 10 minutes. Okay, but program say till the time this data from one single sender or receive client is processing, I don't receive any other data. I don't receive any data. I have to wait till the one processing of data from one single client will done. So this means this program doesn't has a capability of parallelism. What is meaning of parallelism? Parallel. If this program has a capability to receive data from multiple computers, maybe after they receive data, one data may require 1 minute to process, 100 minutes to process. There's a server side programming. Server is running those program for us. Program for us. Okay, but server say no, after receive them data one client, till the time I won't allow a second client. So I can say I can say this program doesn't has a capability of parallelism. Okay, or in this case, if you see here, somebody sent this data to us as a client. They feel they send the data, but server was busy in processing of other client data, so they lose it. Okay, so client lose the information, or client would again resend the data and they receive it. Oh, I don't know why they run so much time here. I don't know what I've written. Okay, time save for maybe 2 minutes. I think might not is going on. Okay, but you get the idea of the parallelism and how to solve this issue. I think you can solve it very easily. Okay, how to solve it? If you want to go for parallelism in this example, that your system IP number 140, IP number 163 send the data in parallel, and whatever data they receive, server receive, they're doing some of the thing on the data. Okay, even though they are busy on other client data, they will also receive other computer data. Let's call parallel or parallelism. So if you want to achieve the parallelism in your server program, again the use case of multi-threading come in play. What is multi-threading? I already explained you, but this is one of the use case of the multi-threading, how to use. So in my multi-threading classes, I already explained you how to use it. So this is the task I am giving to you. Okay, I'm giving to you. You to convert this code, or I can say you to run this code inside the multi-threading. Inside the multi-threading. Okay, guys, can you hold for a second, please? Okay, so multi-threading, guys, you know how to use it, but just if you want to achieve this practical this challenge over here, what I'm talking about, very simply we can do, just convert your code. But you know, if you write this code into thread, if you get 2 thread, okay, it means 2 client can come connect in parallel. If you get 10 threads, so 10 client can connect in parallel. Okay, so it means server is the one, or the programmer or the developer of the server, who they are the one who decide who decide how many client can connect in parallel. Okay, it depends how many thread they create. So by chance, guys, anybody who missed my multi-threading class, a very important class for the technological world, just go through the last classes in the YouTube channel here only. They explain multi-threading, and after, guys, understand the multi-threading, just implement this server program with the multi-threading. It will achieve the parallelism. But while implementing this multi-threading, you will see, if you create 3 thread, 3 connection will connect in parallel. You can connect one by one, I show you already, but I'm talking about in the parallel. Okay, and to demonstrate the parallel, either you run a command that take a lot of time to print and process, or maybe you don't have the command, at least you can delay your code for some second. So it will give you that illusion or that kind of simulation over here that your program is waiting, they're doing some processing, and second program also, or second client also connect, third client also connect, something like this. Okay, but guys, in this program, I'm using UDP. I'm giving you one more task. Okay, one task I've given you, just convert this program into multi-threading, that give you a facility called parallelism. Parallelism. Okay, one more, guys, task I would like to give you here is, okay, if you see, guys, between A and B, let's say this is my Windows having IP 140, this is my Linux having IP 129. So what you're seeing here, guys, Windows is sending some data, and now it is choice of IP1, they are printing this data. But what can we do? Okay, we can create, for example, IP 29 here in this case is a receiver program, and IP 140 is a sender. Now what can we do? We can do one more thing here. We can create a similar receiver program in my Windows or similar sender program in Linux. And whatever Linux will send, Windows will receive. And after they receive, they print. So technically, guys, just by just doing small changes here, okay, just create a reverse program both the side. So if Windows sends something, Linux receive, or IP129 send something, 140 IP Windows receive. And after receiving, they are also printing it, right? They're printing the information or printing the data. Guys, can you do this? Pretty simple. You can create a same program that you create in Windows, in Linux and Linux in Windows. Same program, you can create both the side and run both the side. So you know guys, finally what you achieve by this setup, you can create a chat program. You know, it is exactly like chatting. Maybe you don't have so much facility like emojis or something like this, but basic level chatting program you will create. Windows sending to Linux, Linux is printing, Linux sending, Windows is printing. So both the side guys are chatting to each other. Right now, Windows sending and Linux is only printing. So it is not like a chatting, but yeah, you can achieve some other thing also. Okay, like they're printing here, but I can write one more program in my Linux and they send, and Windows will receive. So it will like a chat program. Okay, and right now guys, if you create chat program with the UDP, and I just tried the attempt, pretty simple to do, but where guys, if you attempt this chat program using UDP protocol, you will see, you will finally somehow create, but it is not good in the terms of managing the code. A lot of issues you will face. Okay, so I'm not discussing here about the issues what you're gonna face. Technically it will work for you, pretty straightforward to do, but you will automatically, if you keep on using this application multiple time, this chat program, you automatically feel this is not the way I wanted my chat application. And all the issues guys that you face, just try to jot it down or write it down. Okay, and you know what, finally you will conclude automatic. I want you feel it, you automatically conclude, we want a chat application but using the UDP protocol for this kind of both the side communication. So technically we are communicating to each other from this side to this side, this side to this side. UDP is not a great choice. So what difficulty you face, I want you feel it. I will definitely explain in my next class, and it will automatically conclude that UDP has some kind of limitations. Okay, and it will automatically lead us to a new protocol called TCP. So my next class is purely based on TCP, and there I explain you. I'm not saying UDP is bad. It's used for some multiple purpose. Okay, but in some of the examples, not only for reliability or non-reliability, there's some other reason also UDP doesn't help you so much. There you have to go for connection-oriented method. And guys, next class will actually explain you what exact meaning of connection-oriented. Okay. So that's all guys for today. I explain you what is a client server and how to use a multi-threading, parallelism, how to make a research program as server and something. So a lot of guys concept I explained to you. Okay, so just do this task and plus try to create some or your own server. Maybe server get the data, send some email, get the data, send some SMS, get the data, store in, provide a web server. Just try it, think. The way I explain you here, I show you today how to create a remote login program or remote not login, remote command execution program like Telnet SSS. But just try to create a program something like this. Try to create some more new kind of server and new kind of idea. So that's all guys for today. Any questions if you have? So I'm enabling your chat window. Any questions you have in today's class, you guys can ask me. Okay, so but very important topic. Okay, I don't see this kind of detailed explanation in any of the document of any of the Python document or any other network programming document in such a base level. But if you have that kind of knowledge, I'm not saying everything of the networking we have covered, but if you have that kind of base knowledge, you can create lots of your own customized services that might not be available in the market. That is one of the intention why we are doing this kind of conceptual program from the basic till all the advanced level. But otherwise, guys, any questions if you have, you guys ask me. Thank you guys very much. Does all the OS are kind of same network? Prakash, it would be anything. You require internet connectivity. You should be in same network, other network. Even though, guys, if you have a internet also, so I can run my program in my laptop. Your laptop is there in the program, other program running in your laptop. Okay, just we require a DAC connectivity. And if you know something about networking, internet, you can use public IP, you can use netting. Okay, just we need a connectivity. Program perspective, program perspective, you don't have to change anything in the code. So somebody asked me, does we use a WhatsApp or same product? No, guys, we don't use chat over the UDP. I have given this task to you. I just given this task to you because I want you to understand the limitation of the UDP. If you don't do this task of chatting program, you can create a chatting program using UDP. But if you don't do create this chat program of UDP, you won't able to understand very clearly about about the limitation of UDP and the power of TCP. Okay, that's the reason I want to do. Okay, so guys, great, Mohammed, right? Can you please teach some edge computing in Earth? Definitely, Abhishek. I'll try. Even though you see Earth program has a huge content, okay, but let's see somehow somewhere. Maybe today I talk in my AWS class about microservices. So we keep on discussing microservices. Maybe like this we will definitely touch somewhere edge computing also. Why different version better? No, I actually Jay Kumar. VM is a name of the OS. VMware is the name of the product. For example, in my laptop, I am using Oracle VirtualBox from Oracle company. Like VMware also have a product called Workstation. But whatever OS you launch on the top of this are known as VM virtual machines. Which is best, Flask or Django? Both are best. Okay, some community use Flask, some community use Django. Okay, so almost everything you can do in the both product is used for same thing, web technology. Right? So both are great. UDP multi-threading. So I think Marin, I have given this task to you, how to create a UDP multi-threading. So this task I have given to you. Definitely in my next classes I'll show you way we can plan, but I just do it. What about RSCSA bootcamp? Yes, Zamir, we will definitely soon we'll do the RSCSA bootcamp if you're the part of the exam. Right now I'm just completing my RSCE program. This is called Ansible, and after doing Ansible, we will definitely do the RSCSA bootcamp. Don't worry. Faizan, somebody asked me if the buffer size is 10 byte. If you send more data of 10 byte, the remaining better data will be discarded. Either you create a loop, they keep on getting the data. Okay, otherwise the remaining part after 10 byte will discard. But if you think your client is going to send more data, you can increase your buffer size. So you do plan a thing of how much data your client will send to you. Okay, so can you teach please machine learning? I definitely try. I've definitely try somewhere we can plan. Okay, definitely try. That's all, guys, from my side. See you in the next weekend. And next weekend, guys, we will talk some more thing about networking and mainly about about TCP. Can you please take some core networking lecture? Yes, Rahul. Even though if you go to my RSCSA training, and again IISc Rise, and RSS somewhere I will talk something. I think two or three basics classes of networking I already taken there. I suggest go through those classes. But networking is big. But at least from those classes you will at least get the idea about basic networking. Okay, so that's all, guys, from my side. We will see you guys in the next class. Bye, take care.